This week we've got an Ash 25 in for a big job. It's an annual inspection with the added bonus of the instrument panels. We're going to be doing a double panel rebuild in this one, and we're going to be documenting the process along the way. So today's job, we're going to be stripping the panels both front and back. We're going to be taking out all of the instruments, the wiring, all the redundant wiring will be cut out and removed. Same on the rear panel. And then we're going to have just the bare panels, which we're going to start doing a composite repair on. And then from that point, we'll do a custom cut exactly how the customers requested it with the layout that they want. When you come to strip your panels, I'd recommend taking pictures beforehand of the front and the back all the way around from multiple different angles. And then when you come to strip the panel, make sure you work from the outside in. If you're planning to reuse any of the switches or circuit breakers, make sure you mark the orientation of them before you remove them from the panel, and also label them so that you know exactly what they were used for before. It would just save you so much time when you come to rebuild.
The last bit of that time lapse, you would have seen us removing some cables. So as you can see, there's quite a bit that we already removed, redundant cables for instruments that are prehistoric and actually predate me. But if you look over towards the glider, you can still see there is a lot of cables left, a lot more than what you would expect for a pure glider. So the next step for us is, we're going to leave some of the old wires and we're going to use them to fish through the new wires. But there is a lot of redundant stuff. So now we have to figure out which sensors. For instance, if Jake comes over here, this lever here has 2 different sensors to make sure it's in the closed position. There's no point doing a full panel upgrade if we're going to leave redundant sensors, redundant wires, because you can't maintain it. You will not be able to figure out which cable is actually being used for something and which cable isn't. Any issues in the future, whether it's a GPS problem, a power problem, you won't be able to figure out what's going on if you have this mess of wires behind your panel. The other issue of this panel, well, this wiring as well, is a lot of it was run, actually you can see it here, along the side of the seat pan. This glider has built-in channels in here and in here and in here, where the cables are supposed to be run, which is what we're going to fix as well. Now, if Jake comes over here, here are the instruments we removed, and a lot of them are quite old, still a lot of them quite good. We're going to be reusing a lot of them. One of the interesting things is, for instance here, you can see the sun damage. This happens when the canopy is left open on the grid and it focuses the light and leaves a lovely bird mark. Thankfully, we're replacing these, and we're replacing them with 2 LX9000 systems, 9050s? 9050s. But you may have noticed these will not fit in the old panels because the cutouts are for circular instruments, not for square ones. So now Jake is going to show you how to fix a panel.
We've got the panels here. So the last time you saw these, they still had all the old instrument holes in, and we just stripped them. After that, we've got rid of all the screws and we've got rid of the labels, panel labels. And Colin's now cut out around all of the old instrument holes with a Dremel. We've tried to leave as much of the original panel as possible where we can. And then once we've cut that out, we've then scarfed back, or you could say chamfered, the structure that remains. And now the next job is to lay up 8 layers of new glass cloth into the flange. We're going to lay it up on a flat glass face, and we're going to show you a bit about exactly how we do that in a minute. Once that's done, we're going to weigh them down with batteries to make sure we get a nice flat finish. And same with the rear instrument panel, that's all done, ready to go. You know it's ready to go when you've got a really sort of sharp edge all the way round. Really important when you're laying up onto a glass surface like this that you use mold release wax. If you don't, you'll be breaking the glass to get the panels off. Don't ask me how I know that. So here Colin's just applying that wax, give that 10 minutes and then buff it off and you're good to go. We put the panel face down, apply a small amount of neat resin over the bonding area. That allows the thickened resin to bond properly to the panel. And then you want quite a generous bead of thickened resin to go around that join between the old panel and the glass. And when you're laying up, make sure that each layer, the glass cloth is fully wet out before going on to the next layer. There should be no air bubbles. On this panel we did 8 layers, and then we finished it off with a layer of ripstop. The ripstop just allows the excess resin to come out of the back, and it makes sure that that final layer is bonded properly to all the previous. And here Colin's doing the last panel on his own, exactly the same process as the first panel. Once it's all laid up, then you just want to weight it down to make sure that the panel sits flat on the glass surface. We just used old lead acid batteries for this.
So it's up the system now.
Panels have all been laid up. We've let them go off 24 hours and we're now going to try take them off the glass, see how they go. Just before we do, how did you find that, Colin? That was your first time laying up the panel.
Not too bad. The smaller panel, a little bit more difficult just in regards to keeping the riv nuts in situ, but as long as you've got the fibres around it, it wasn't too bad.
Yeah.
Just time consuming.
The key bit, as we've explained earlier, is just making sure it bonds well on that where it overlaps the old structure. Right, let's see if we can get these off. Oh, before we do, always make sure that the resin has actually gone off. So try and compress the cups, scratch the surface, and it shouldn't feel tacky. You shouldn't be able to dig your nail in. So we know it's ready to work on.
Yeah, that's clear.
All right. So you should just be able to carefully peel it off. Just get looks pretty good. Spot on.
There we go.
Perfect. So that's what it looks like after it's been done. What we're looking for ideally is no voids in the join. So that's all been filled with thickened resin and we've had quite a bit of squeeze out, which is good. So it means that there should be a good bond between the new and the old glass. There's the original mounting holes we can still see for the front panel, so that's handy. We can just re-drill those out. And your panel?
Yeah.
All looks good. Yeah.
Everything looks okay.
So now we just peel the peel ply off. We're just looking for any big air pockets, particularly again around the join, but that all looks pretty good. We can feel, when we feel the back, there is a ridge, a noticeable thicker area where the old panel was. That's to be expected.
Yeah.
And in our sort of post-processing, we're going to get the high-speed drill onto this and just take some of that thickness away to try and get a nice flat surface on the back, or a more flat surface, I should say, on the back. But before we do that, we're going to leave it for 15 hours on 55 degrees to post-cure.
When you say we?
Well, Colin's been doing most of the work, so we'll leave it to Colin, I think.
What we're going to do is put the heat lamp directly over the two panels, try and get them up to 55 degrees for a full duration of 15 hours. If you can't achieve the full 15-hour duration in one go, it is okay to stagger it. So given the time of day today, we'll probably do 3 hours today. When we get back in the morning, try and see the remainder through in one hit if we can, or stagger it slightly if we have to. So we'll just get it set up close enough, but not too close that we melt everything. Try and direct it onto the panels. And then what we'll do, just using temperature gun, just check the temperature every couple of minutes, just until we see if we can get up to 55 degrees and maintain that then for the duration of the post-cure. It's always a good idea to make sure you remove anything that's flammable that you've been working on. So I'm going to remove the resin that we've been using. I'll make sure Dougie's far enough away because he's a hazard. Yeah. So the post-cure's all complete. We've had to flat the panels back down now, as you can see on these. Everything's looking a lot neater than it was in the last scene. So what we've done is we've flatted the front, tried to get it nice and smooth, free from any voids all over. And the same on the reverse side, so everything's all been flattened nice and smooth, taking it as far into the corner as we can to give as much surface area for the back of the instruments that are then going to be laid inside. So that's the back panel done. Same on the front panel. Because this one had a slight twist to it when we took it off, we've since heated it up, straightened it out. We end up with one slight little ripple in there when we were flattening it back, so we've got a little bit of filler, skimmed it back over just to get it nice and smooth front and again on the reverse side, trying to get all the way into all the voids there.
The next job is to find the midpoint of both panels. So we're just going to get a ruler or a measuring tape And what I tend to do is measure across the panel at various points, maybe 4 or 5 different points vertically along the panel, and just put a little pencil mark down. And then I fit a line of best fit on the panel. So we'll then get a ruler and try and fit a line of best fit. And you've got to remember, these panels aren't symmetrical. This has been hand laid up in a handmade mold. So you kind of just have to do your best with it. As long as your line of symmetry looks pretty central and looks vertical, then you should find that by the time you've laid all the instruments into it, it should look nice. So we're going to do that on that one, and then same on this one, a line of symmetry. A bit more difficult at the top here because it starts to curve around the top, but again, just do the best you can. Once we've got that line drawn on both panels just in pencil, we'll then get some white masking tape, and we'll butt the edge of that masking tape right up against that line, and then lay masking tape across the whole panel. And basically what we're doing is we're creating a surface that we can now draw on to make sure that we're going to fit all the instruments in. We've then got all of our templates. So these templates are available to buy from Navboys. We use them all the time for this job. But we've got a rough idea of what the customer's looking for here. And we basically now need to make sure that that will actually fit, that will actually work. So we'll start laying up all of the instruments in their respective places, making sure that it looks like, on the face of it, everything's going to fit. Something like that to start. We'll finalise the positions and make sure everything's symmetrical later on. But once we know that it's going to fit, we'll then have another look in the glider, make sure that there's nothing behind the panel that's going to obstruct any of these instruments, so that you can see that they're all different depths. So you need to consider what's behind the instrument once it's fitted. And then once we're convinced that there's no issues with the layout, that's the point where we'll start marking up the panel and then cutting. Most people, they tend to look for the biggest screen possible. So in these ash panels, because they're quite small, they're actually quite constrained because of these big leg cutouts. You can't actually fit a huge screen in them. So we've gone for the smaller LX9050 screen, which is a bit narrower and a bit just a bit narrower, which basically means we can fit more instruments either side. But yeah, usually everyone wants the biggest screen they can go for, and then try and work with whatever existing instruments they've got. So you can see the existing instruments that we're going to be reusing from the customer's old panel. Here Colin's just finding the midpoint of the panel. So find the midpoint over various locations down the panel and then draw a line of best fit. But once you've got the panel taped up, the next job is to go and find where any restrictions might be. So you can see on the front panel we've got the mounting points that we need to be wary of. And we also need to check that the depth of the outer meter isn't going to cause a problem on the mounting arms. On the rear panel, we've got quite a big cross brace immediately behind the panel, which will affect how deep the instruments can be right at the bottom of the panel. Now that we know about the restrictions, we can now start marking up the panel. When it comes to marking up the instrument positions, we always measure from that midpoint, and that ensures that the panel will be symmetrical and it will look good to the eye. And once you're happy with the final layout of the instruments, it's time to start cutting. We like to use a Dremel to do the LX9000 hole. We cut it quite undersize and just do a rough cut, and then we gently file it out with sanding blocks and files to get it to the final shape. That creates a really nice cutout for the 9000. When it comes to doing the instrument holes, we like to use a drill with a hole saw, usually just a 57mm hole saw, and then a 79mm hole saw for the 80mm instruments, and then we gently sand them out with paper. It's now time to dry fit the panels. So we refit all the instruments and then go and fit the panels into the gliders to make sure that there's not going to be any issues. So now that the panel's cut, it's off to go and get painted in Nextel. The next episode is going to be a lot more wiring heavy. We're going to be teaching Dougie how to solder the power wires. You're going to watch us run cables from the front to the rear panels, and you're going to see how this all comes together in the final assembly. Stay tuned.